Okay, so now I'm going to talk to you about Distributed Application Runtime, or Dapr. And Dapr is how you write your applications. It's about writing code, so it's about how you build distributed applications for the cloud and edge. So what developers find themselves doing today is that they've been asked to build effectively these scalable distributed services. If you want to provide a service to someone, you want to expose that out as a scalable service that can be typically built with a sort of a microservices architecture. And what that means is smaller pieces of code that are versioned, can be upgradable, deployed frequently, and you build these as services. This is different from, say, a typically, a 3-tier database application that was just sort of a line of business application. These tend to be services that you're scaling out. And what's happening is that developers are asked to write these in many different ways, in many different languages. These are developer languages in Go and Python and Node. And quite often, of course, you don't necessarily start from scratch, but you want to bring some existing code with you. So in building these services, a typical service might look something like this. You have it built with many different languages. The front-end service here might be written, say, in Node, and some of these other services here may be written in Python and Go in different languages. Some of them are stateful and have state associated with them. Some of them are sort of stateless. And some of them often integrate with external systems that you want to talk to, like databases or queues, and of course, frequently open up endpoints like this. So, this is just a typical example of a shopping type application that might be required to have, a shopping cart state, how you email your clients, do payment systems, look at inventory, and all of these may be built by different people in a team, and of course, as we've just seen, described as an application and deployed into an environment. But the question is how do you help developers write these pieces of code here? Because some of them, there are hard distributed systems problems that you need to solve and capabilities that you need. And so that's what Dapr does. Dapr, it helps you write your code for writing those services. And it focuses a lot on event-driven applications where events come into your system, and it makes it easy for developers to build applications that consist of a microservices architecture, whether they're built with stateless or stateful, and of course, whether they run on the cloud and the edge. And the reason why you want something like Dapr is because there's challenges that developers have today in terms of what currently on offer. Quite frequently when you build out with a runtime today, say you choose Node as a particular runtime, you're only limited to particular capabilities of that environment. You may only be able to build like stateless applications that have, when they fail over, have to recover all their state again and get lost. Or it may be that some applications don't integrate with some external systems. Frequently, you might have to have some existing code that you want to port and integrate with. If you look at some of the Azure Functions and some of the FAS frameworks, the approach there very much is you have to throw your code away and start again, and that's not particularly effective. And then quite frequently as well is that, as we talked about, some applications are built with one language, some part of the application is built with one language and others are built with a different language, and you'd like to be able to compose those applications together and incrementally adopt new technology into them. So these are some of the challenges you have on top of building those capabilities. And so Dapr helps solve those capabilities by bringing along a set of building blocks. These are sort of capabilities that you can bring into any application of your choice. So the key concept of Dapr is that there are these capabilities. You can use them, and you can choose one of them or two of them or a few of them, depending on the problem you're trying to solve with the language that you're using and your framework of your choice. And it does this by introducing a sidecar to your application for those capabilities. This is sort of an architectural approach. And importantly, you can run these applications. The implementation of Dapr allows you to run it in multiple different environments. So in the same way, OAM is implemented in different environments, the idea of Dapper is I can take my implementation, my code, and I can run it on one environment here, say on this Kubernetes cluster here, but I can also go and run it on, say, IoT edge devices or another environment. So portability of your code across multiple environments is also key. So I think this is probably the kind of most important picture from a takeaway perspective of what Dapper is. At its heart, it provides a set of standard APIs that can be accessed over HTTP or gRPC. So you can call the capabilities. So here's your application. Here's Dapper. You call over HTTP or gRPC protocol. And then Dapper provides an API here with a set of capabilities that you can use. And it does this through a local host URL format. So here, my application calls onto 3500, and then this is the syntax here, saying version 1, I call the invoke method. And this particular example, one of the capabilities that Dapper provides is for one piece of code to call another piece of code, one service to call another service. So my shopping cart service may call my email service. And it does it then through this consistent syntax like this. So in this particular case, I want to invoke the method here called new order on my app, on the application called my app. So this sidecar architecture gets dynamically loaded. And if you look at the next, we'll get to that picture. And then those capabilities can be called onto any particular language. So I can call it from Go or Node or Python or any framework of my choice because of the standard HTTP gRPC API. So that provides the abstraction that helps you on these things. And then Dapper itself can run on any cloud and edge environment. So you get this implementation of a runtime exposing a protocol to any framework of your choice that can run on different environments and makes it very portable and makes it very flexible. When you host Dapper and you launch an application here, so when I launch an application here that consists of many services, in this case service A and service B, each instance of my service has its own Dapper sidecar running, and each instance of the service talks over locally over the Dapper API to its relevant instance. So now the overall application here can take advantage of a calling from application A to application B because all the calls go through Dapper and then they go through the calling mechanism that gets provided by Dapper, the messaging mechanism to invoke methods on another service. Or a piece of code here can save state into a state store here, or it can publish messages between services. And what's very, very important and key to Dapper is that you can plug in different components for how it stores state, how it publishes and subscribes between the Dapper instances, and importantly, to external resources. So I can trigger my code by having an event that comes into a Kafka queue, and that gets pushed and notified to Dapper, and then Dapper calls my code. And so this ability to have this abstraction where I can plug in multiple different components for all sorts of different triggers from external systems makes it very flexible. So I might write some code that says trigger my code because a message comes from a Kafka queue, but I don't have to change my code if I want the trigger to come from, say, RabbitMQ queue or a Event Hub queue or some other queue. And my code remains the same. I just need to say how the event got signaled. When you look at one environment that Dapper will run in is Kubernetes. But it'll run in many environments, and we'll make Dapper run in Cloud Foundry and Docker Swarm and IoT Edge and Kubernetes. But in Kubernetes particularly, we've done a first-class implementation of Dapper, which has CRD operators here. One of them is a sidecar injector, and this runs inside Kubernetes so that when I launch my application here, and it runs inside a pod, it launches, this code indicates that it wants to have a Dapper sidecar, And so this sidecar injector sees that in the service deployment and deploys an instance of the container inside the same pod as my container. So these all run inside the same pod, talking over the local API, because the sidecar injector pushed this into the pod where my container was running. And then there is inside Kubernetes an operator here that pulls out events from external systems. And so if I change how this gets configured, it does this configuration here. And so this first class experience allows you to have Dapper running inside and invoking methods, invoking services, and providing capabilities for your application. So the 6 things that Dapper provides to you, and we'll go through and do demos, is that Dapper allows you to make your code stateful. That means if I have like a shopping cart and it has some inventory inside it and it dies on this machine and I start it over here again, it'll recover and remember all the contents of the shopping cart, as an example. So stateful, long-running things. So this is super important because most things have some sort of state hanging inside them. I can call between my services. This is service invocation. So this is one service can call another. I can do triggers from external systems. That's called resource bindings. This is event triggers. I can publish messages from one service to another. So I can say, for example, I'm going to publish that I've processed a business event, and then whoever's listening on it can pick that event and do something with it. So this is classic publish and subscribe. We implemented a particular thing called actors. I won't spend too much on this, but this is, think of them as little objects with code and compute that can run in the millions, and you can make them represent any object of your choice. And then distributed tracing. This allows us to see calls between your services and trace diagnostics. So these are the building blocks, and I can hook these up into my application, and I can use them, using local call APIs. So let's run through an example in slide, and then I'll show you a demo. So for example, if I wanted to make my application stateful using the state management API, I can use Dapper for that. And that means I can say, I want to call out onto my local host endpoint here and call the state API here. And I can give it a set of key value pairs inside here. So the capability for state management that Dapper provides is the ability to store key value pairs in a state store of your choice. So here I've got key value pairs of weapon and Death Star and planet, which is Tatooine in some way, and these get pushed into my state store here. So this can be Redis or Cassandra or CouchDBase or Google Firebase or DynamoDB of your choice. And if I go and look at that state store, I'll see the state inside it all. And then equally, if my application wants to get back the state for a particular key, in this case the planet key, I can call on to the endpoint here. It's like providing the key that I want, and it will call through to Dapper, it will call through to my state store and return the value of this key back to my application. So this now means that through this standard API here, my code is consistent, independent of the store I store it in, and it can be used, and it's very simple to call, because I can call this thing in most languages. So in Go, I can call it like this, or Node, or Python of my choice. Same thing if I want to call from my front-end service here to a back-end service, I can use Dapper to call the invoke method. In this case, I'm going to invoke the cart application. This is the cart application. I can call a method called checkout, and I want to provide some particular data. This goes through Dapper, and then how I do from one call to another and marshal that call across can be plugged in through different implementations. In this case, there's a Redis implementation for marshalling that call back to the cart here, and then Dapper receives the call here from the front-end application, and then it calls onto my particular checkout here. I asked it to call a checkout method. Here's the checkout endpoint on my application, and it takes the content of the message and sends it to my application here. So I can call So Dapper will allow you to discover where an application is, usually using the framework, the platform, sorry, and then calls the method it wants. So let's go and see what this looks like. I'm going to switch mics. Can you still hear me on here? Right, so we're going to see a demo of this, what this looks like. These are all our samples that we have for Dapper inside here. And this is a demo application here that saves the state of a shopping cart and issues orders. So this particular Hello World application here, this is a Node application, and you'll see that this just opens up, this is just a simple Node application, and I've got two methods inside here, order, and I've got new order. And my new order method is very simple. It takes a new order here, it looks at the body of the message, it looks at it takes out the order ID, it builds this data structure here with the order ID and the data, and then this is the key part here. It calls on to my endpoint here with the state value here, and it calls on to the URL endpoint here, the state URL endpoint, and this state URL endpoint here is simply the way I describe calling onto Dapper here. So I call on to the Dapper endpoint here, calling it with state. So this allows me to call, this new order here allows me to store state inside Dapper, and then the order endpoint here allows me to call onto that state endpoint again, handing in an order key to retrieve the state, just like we saw inside the slide. So now I can call on to the state URL endpoint, and I can take that order state back and see the state. Getting started with Dapper is very easy. If you go to, let's see if this is working here. If I go to, if you go to Dapr.io, it's just going to load. Huh. Let's see if this works. Network connectivity? Yes. Well, so, but if you go to Dapr.io, there's a script and you can download Dapper with. Let's see if that one's loaded. And once you've downloaded Dapper, you can do Dapper init like this, and it will configure this on your local machine, and then you can start using a Dapper CLI to issue commands. So one of the commands you can issue is you can issue Dapper run, and this runs an instance of Dapper and hooks up your application. So in this case, I'm going to run Dapper as this Node application here, which is this Node app here, this app. Sorry, I'm going to run an instance of my application here, and I'm going to give it a name called Node app. I'm going to launch a particular port that it's listening on. Here's the port for my Dapper instance, and then here's my Node code, which is this one here. So if I run this, it launches Dapper and an instance of my application running next to it all. And now I have, if I actually go off into another console here and I do Dapper list, I can actually see that here's an instance of my application, Node app running, listening on this port here inside here, port 3000. So I can now inject messages into this. So what I'm going to do is, just to show how this works, to show the simplicity of using the API, I can call that particular endpoint inside here through Dapper. So remember, Dapper is running on port 3000 here, which is this port here, and I can call the new order method inside here. So if I give this a new order, and I'll give this order 8000 like this, and I hit send on this, then this now is called through to this new order endpoint inside here, and it's got my new order here and persisted this successfully, because all I had to do was call onto the new order endpoint, and then Dapper took care of saving all the state. And equally, if I go and now do a get, but this time I do a get on the order method, and I provide a call onto this particular key here, you'll see I'll get back the value 8000. and this was because it persisted the state when it called the order method here. So this is how I made my application run with Dapper next to it all, by simply running the CLI inside here, and now I Dapper enabled this application. But to show you method invocation, I can actually now take another application here. This is this Python application, and you'll see now that here I can actually call onto the invoke method and invoke this new order method here. So this new order method is this new order method inside my node application. And I can build out the order ID inside here, and I can do the Dapper URL post onto this. So if I go, and I think I have it inside here. If I now go, and do Dapper run, and this time, I'm going to make sure I'm in the right directory. Am I in the right directory? The app.py. Oh yes, here we go. Yes. Yeah, this should run. So if I now go and run this Python application, I can actually call using the invocation method here onto the Dapper endpoint method inside here. And you see now I'm having one service. If I go and look inside my Dapper list inside here, I've got two applications running. One of them is my node application here when this returns. This is my node application, and then this Python application calls from this to the node application, and it issues those orders. So the Python application is issuing these orders here, and then I'm seeing these orders appear inside here. So now I've done very simple, by using just all I had to do was make this invoke method here call the new order method on another service. Dapper took care of all the hard problems of where the service was running, providing the right parameters, calling the right endpoint. If the other method fails and goes onto another machine, everything keeps running. And I didn't have to do very much other than know how to craft up a URL like this inside my Python application and start it with the Dapper as running as a sidecar next to it all. Now I can take this exactly the same, this application, and I can go off and put it into a different environment. I was running this on my local machine, but say I wanted to run it on a proper distributed environment, distributed systems environment. I wanted to run it inside a Kubernetes cluster. So I can do that. Let me just stop this here at a moment here. If I go off, actually, out of interest, all the state inside here, I can actually attach to, if you go and see inside here, just to show you what was happening, if I go and do a Docker PS, you see that locally I was running an instance of a Redis container here to store all my state. This is just a default environment. I can plug in any state store here. And you can actually go and attach to that state store inside here, which this was the Redis state store here, and it was hget all, isn't it? Oh, it was hget all. Actually, no, it was get keys, wasn't it? You can actually see here's all of the state keys that I saved. So here was the node order app key, and then if you do hget all on the node app dash order like this, you can actually see the order information that gets pushed into the order here as I was pushing those orders. So you can actually go and look at the state store inside here, and it's stored in a very consistent format. But let me, if I now just show you a Kubernetes cluster, I have a Kubernetes cluster here now where I've deployed Dapper into this. And it's very easy to deploy Dapper into a Kubernetes cluster. You just have to do Dapper init --
Kubernetes like this. And this will deploy Dapper into my Kubernetes environment, and I have Dapper running here, and this does all the hard work of launching Dapper as a sidecar. And I've deployed the same applications here, the Node application and the Python application. And I didn't have to change any code. It was exactly the same code as I had running. But this time, all I had to do was, in my Node application, is I had to write a Kubernetes deployment manifest here. This is a Kubernetes deployment. I had to give it the name of my Node application here. And then all I had to do was provide these simple annotations here. And these annotations were like the command line. So as we saw on the command line, I'm launching this Node application with a particular name called Node app, and it's listening on a particular port. And this true here means it will launch Dapper as a sidecar. And I could do this with the Python application here as well. The Python application is a Kubernetes deployment, and it launches the application here with a name called Python application. So this name here is this name here, and then you have the Node app inside here running, and these have both been deployed. And in order to do that, you simply just have to do kube apply on those manifests and deploy them into this environment. And so now what I'm able to do is I can do, I can actually see that there was an endpoint opened up for this Node application as part of that deployment. And you're able to, here is the my Node application, here's this Dapper sidecar running, here's the Python Dapper sidecar running, and there was a service endpoint here that I got opened up for this. And if I go and, well, it did come back in the end. If I go and push this inside here and do order inside this, you can see that I can get back the order for my application that's running inside here. So same application, Node application, but this time I described and told Kubernetes about my application and deployed it into the same environment here. No code changes in any way, running but in a different environment. So that's how I use Dapper here for service invocation. But there are many more capabilities that you can also do that bring powerful capabilities to help you run and build these distributed applications. And I think one of the most important ones is this concept of bindings. And bindings allows me to have my application post an event into Dapper about how I want to send something or receive something from an external system. So in this particular case, I want to post a message here that contains some data here onto an inventory endpoint, and Dapper will map this and send it out, whatever inventory is mapped to, into some external system. Or I can take input bindings where I can have a message from Kafka, and I want Dapper here to trigger a piece of code. In this particular case, I have an endpoint here called trigger, and I can say when a message arrives on Kafka queue, trigger or call the trigger endpoint, providing me this data. And this means that I can easily now take my application and have external systems fire events inside me, or I can fire events out to them. And all of this is fully pluggable, so I don't have to change my trigger code if I wanted to move, say, from Kafka to Redis, or I wanted to move from Redis to SQS. So I can change these components here without having to change my code. My code remains the same. These let's see a demo of what these resource bindings look like. So these bindings, if you go to the Dapper, if you go to Dapper, if you go to Dapper, there's a components repository inside here, and these components are all mapped to particular types of capabilities. So for state store, for example, I can plug in all these different types of stores: Cosmos DB, Cassandra, Couchbase, And for the bindings here, I can hook in different types of events from different providers. So these are external things for AWS. So I can be triggered off DynamoDB or S3 or simple notification service. So let me just show you an example of what this looks like from bindings, because this is a pretty cool way of using Dapper in your components. Here I have a Node application again. This is a Node application that I've used. There's Node Express, and it has one endpoint inside here called sample topic that I can call. And then and this is my trigger. And then I have another application here, which is a Python application. And this just creates a URL like this that uses the bindings concept and posts to sample topic. And it could just post data for orders to this endpoint. But I want to push this, I want to make my Python application trigger events through to my Node application. And for that, I can run and use, for example, a component like a Kafka queue. So in this particular case, I have a Kafka queue, which is hooked up to sample topic, that's configured to receive events and post events onto the sample topic endpoint, so that I can send messages from my Python application to my Node application. So if I go and, I think I've got inside here, I've got Docker PS running. You'll see that I actually have running locally, I have Kafka running locally here on my machine. So what I can do is I can actually run here, I can do Dapper run, and I can launch the Node application here, listening on that Kafka queue. And it'll receive events from Kafka. And while that starts up, I can actually go to, was it here? No, it was this one here. No, this one here. And this one here, I can launch my Python application here using Dapper run, launch the Python application that posts things onto the Kafka queue. And if everything's working well, here the Python application is posting orders, order 1, order 2, order 3. And then if I go back here, you'll see that my Node application is receiving orders, post through Kafka. So the Python application is simply writing orders to, the Python application is simply writing orders to sample topic like this. And it's configured to say, I'm going to use the Kafka binding, and then the Node application is just having this sample topic endpoint, and it's receiving these hello from Kafka via the Kafka binding. So this is how I can do triggering mechanism with absolutely anything. And here you can plug it in yourself. So that's triggers and bindings, and that's pretty important for you to build distributed event-driven systems. So you can go further than this. You can also do publish and subscribe with events. So here I can publish events for other people to listen to. So if I want many applications to listen on my events, I want more than one application to receive the order event, they can listen on the order event here. And then when I publish the order event here as a topic, so I'm listening on the order event here, more than one application receives it. So this is very powerful if you're wanting to do a broadcast, or a particular set of services want to see events that happen from others. And then we also do the concept of tracing, and Heishi's going to do a demo of this in a moment, where I can call between one application and another, and because Dapper sits in the middle, we can provide lots of important information about how the calls are traced between those services, in terms of metrics and seeing what the call events that happen, and plug those into any system of your choice through open census or open telemetry, so you can start to see and then push that data into something like Azure Monitor or Prometheus or anything of your choice that runs OpenTelemetry. So it looks like this. I have this application call another application. It posts OpenTelemetry events, and they plug into all of these different providers here that allow me to see what happened when Dapper was sitting in the middle here between these two applications. I'm going to let Haishi now take over and do a couple more demos on what this is like. And because you're going to do one on OpenTelemetry and then the dashboard, aren't you? Okay. Shall I switch? Yes, you can sit here.